Vol.3. Data structures. The OS does not store process information in one place. It uses a web of interconnected kernel objects. Understanding ETHREAD, the VAD tree, and the PEB gives you total visibility into any running process and any attempt to hide one. ETHREAD is the kernel object representing a single thread. Every process spawns at least one. ETHREAD contains a pointer back to its parent E process, the thread start address, its thread ID, and CPU context. When malware creates a remote thread, a new ETHREAD appears in kernel memory. Volatility finds it. Inside ETHREAD lives NiThread, the kernel dispatcher object. NiThread holds the thread stack pointer, scheduling priority, and its trap frame, the CPU register snapshot taken at every system call. Reading NiThread gives you the exact CPU state of any thread at the moment of memory capture. Every process tracks its virtual memory through a binary search tree called the VAD virtual address descriptor. Each node represents a contiguous memory region. The VAD stores start address, end address, and protection flags for every allocation. Injected shellcode always creates a new VAD node. It cannot hide. Walking the VAD tree exposes every memory region a process owns. A clean browser has predictable entries stack, heap, loaded DLLs. A compromised process has anomalies, executable regions with no backing file, read-write-execute regions in unexpected locations, private allocations at suspicious addresses. The VAD does not lie. The PEB process environment block lives in user space at a fixed offset from the process base. It holds the image base address, the loader data list of all loaded DLLs, the heap base, environment variables, and the command line. Volatility reads the PEB without executing a single API call. The PEB loader data is a doubly linked list of LDR data table entries. Each entry stores the DLL base address, its full path on disk, and its size in memory. Rootkits unlink entries from this list to hide modules. But the VAD still shows the memory allocation. Cross-referencing PEB against VAD unmasks hidden DLLs. 3 detection vectors from one dump. Malware that creates a remote thread leaves an ETHREAD with no legitimate start address. Shellcode injection leaves a VAD node with read-write-execute protection and no file backing. DLL hiding leaves a gap between PEB loader data and VAD entries. All detectable. All in RAM. 3 volatility commands for this chapter. Windows.threads finds all ETHREADs including unlinked ones. Windows.vadinfo dumps the full VAD tree for any process. Windows.list reads PEB loader data to enumerate every module. Run all 3. Cross-reference the output. Anomalies are your evidence. Tomorrow, Vol.4 process analysis.